In this video, we will study the classification of elements and periodicity in properties. We'll cover why classification matters, a brief history of the periodic table, the modern periodic law, periodic trends in properties, and the naming of elements with atomic numbers greater than 100. First, why do we classify elements? Classification organizes elements in a logical way, helps us predict properties, and reveals patterns in chemical behavior. Now, a brief history. Dobereiner introduced triads. Mendeleev created a table based on atomic mass, and Moseley established atomic number as the correct basis. The modern periodic law says the properties of elements are periodic functions of their atomic numbers. This is why the periodic table is arranged by increasing atomic number. Here is a simplified version of the modern periodic table, organized by groups and periods. Groups are vertical columns, and periods are horizontal rows. Next, let's visualize key periodic trends: atomic radius, ionic radius, inert gas radius, ionization enthalpy, electron gain enthalpy, electronegativity, and valency. Atomic radius generally decreases across a period because nuclear charge pulls electrons closer. It increases down a group because new shells are added. Ionization enthalpy generally increases across a period because electrons are held more tightly. It decreases down a group because electrons are farther from the nucleus. Electron gain enthalpy and electronegativity also tend to increase across a period and decrease down a group. This reflects a stronger attraction for electrons across a period. Ionic radii depend on charge. Cations are smaller than their atoms, and anions are larger. Inert gas radii are typically larger because of filled electron shells. Valency changes across a period. It increases from 1 to 4, then decreases back to 0 for the noble gases. Finally, elements with atomic numbers greater than 100 use a systematic naming scheme. Each digit has a prefix, and the name ends with "ium." For example, element 101 is unnil-unium. That wraps up the overview of element classification and periodicity. Understanding these patterns helps us predict chemical behavior across the periodic table. Thanks for watching.